Okay, so we are in section 14.4 where we get to solve trigonometric equations. There's not a whole lot difference from solving regular equations than it is for solving trig equations. All you have to do is, first thing you have to do is either do one of two things. You're going to factor by either using the quadratic formula or simply isolate the trig function. And once we do that, we get to take the inverse trig function of each side to get a value for our variable. Now, our variable is specific degrees in radians on different points in the graph, depending on if it's one of the 6 trig functions, depending on which that may be, whether it's positive or negative, or if it's squared or if it's not. So I'm going to show you, this is going to do part 1 of 14.4, where we're going to solve trigonometric equations first off in a general solution. And then the second part of this for today will be what we do and if we have an interval. So we have some type of parameter we have to go by. So if we look at the examples here we got A, B, C, and D. For A, we have 2 times the cosine of x equals the square root of 3. Now, what you need to do is just pretend that the cosine of x is just like a variable. So you're going to solve it just like you would do any other equation as you had a variable. So like for instance, pretend that you have, like it was 2y equals the square root of 3. You would just divide by 2. So then y would equal the square root of 3 over 2. You're going to do the exact same thing to example A. So you're going to divide both sides by 2, which then gives you the cosine of x equaling the square root of 3 over 2. And then what you're going to do is you're going to take the inverse cosine of the square root of 3 over 2, which will get you your x. Now, you can either do that, or you can go and look at your unit circle handout, which I gave you in chapter 13, and you notice that if you look at cosine and you look at square root of 3 over 2, which is right here, you realize that the inverse cosine of the square root of 3 over 2 is going to give you 30 degrees. So if we go back to over here, we know that x is going to equal 30 degrees. But in radians, it actually equals pi over 6. But if you look in the directions, it asks for all general solutions, which means that it doesn't matter how many revolutions it goes around that graph, we want to find the value for the square root of 3 over 2. So the first one is going to be pi over 6 plus n times 2 pi. Now, n is how many revolutions you want to go around our graph. Is it 1? Is it 2? Is it 10? Whatever it may be. So that's one answer. The second answer we have to keep in mind is dealing with our reference angles. And again, this is our chart. Our unit circle chart is going to help us that again. And we're going to look into this box here for our different positive or negatives for different trig functions in different quadrants. So it ended up being a positive square root of 3 over 2. Cosine is positive in 2 quadrants. It's positive in quadrant 1, and it's also positive in quadrant 4. So that means that there's a degree in radians that's also, if I take the cosine of that radian, I'm going to get the square root of 3 over 2. And how we find that is this. Let's say we go up to the unit circle here, and we figured out that 1 our one reference angle is right here. Well, I know that the other reference angle will also come up here, right at 11 pi over 6, because this reference angle will give you 30 degrees, just like this one will. Okay? So that means that you can now also write that it's going to also be 11 pi over 6 plus n times 2 pi. So there's your two answers. So when you have a value, an initial trig function that is just 1 degree, you're going to get two answers. Okay? So let's give a try for example B. Going to do the exact same thing, so I'm going to subtract 9 to both sides, just like tangent x was a variable. So that leaves me with 7 tan x equals negative 7. And if I divide both sides by 7, I get tan x equals negative 1. And so if I find the inverse tangent of negative 1 here, that's going to equal, actually in degrees, it's going to equal a negative 45. So in radians, that's going to give me a negative pi over 4. But what I want to do is I want to find the positive ones of these. So if I go back to my unit circle, let me do some erasing from previous ones. So if I go back to here, they told me that it was a negative 45 degrees. So negative 45 degrees will land you right here. It'll land you in a positive 7 pi over 4. But what we also have to keep in mind is that since it was negative, tangent is also negative in what other quadrant? It's also negative in quadrant 2. So if we go back up here, our means our reference angle from here to here will also be 45 degrees, or pi over 4. And the other interval is also going to be 3 pi over 4. So when I go back to here, I can rewrite this as 7 pi over 4 plus n times 2 pi, and it's also going to be 3 pi over 4 plus n times 2 pi. Okay? So those two examples showed trig functions that were in 1 degree. These next two are going to have squares attached to them. The only difference is instead of us trying to find either positive or negative trig patterns, it's going to be both positive and negative because of how you're going to solve it. You're going to solve it just like you were, like say a variable was squared. So you're going to isolate that squared variable. So we're going to isolate cosine squared x. So first thing we're going to do is we're going to add 1 to both sides. So I'm left with 4 cosine squared x equals 1. I'm going to divide both sides by 4, so that leaves me with cosine squared x equaling 1/4. And then if I take the square root of this, I get cosine x equals plus or minus 1/2. And so this is just like when we isolate a variable, and when we take the square root, we must use plus or minus. It doesn't change just because of trig functions. So now here, I have to find x. So if I find the inverse cosine of plus or minus 1/2, so that's going to equal plus or minus, it's going to be pi over 3. So if you looked at, checked the unit circle, checked it there, and now what we have to do is, since we have both positive and negative values of cosine, I have to use the reference angles for all 4 of them. So I have to use the reference angle here, that's pi over 3. I have to use the reference angle here, that's pi over 3. I have to find the reference angle that's here, that's pi over 3. And then the last one, I have to find the reference angle from here, that's pi over 3. So all 4 of those points are going to give us a correct value for x. So using the unit circle, using the proper proper rules in angle development. You know, halfway here is 180 degrees, a full revolution is 360, and then determining which value in radians that we're going to have that's going to be sufficient for these equations. And so the first one we know that it's going to be pi over 3 plus n times 2 pi. That's the first one. And then the next one's going to be 2 pi over 3 plus n times 2 pi. And then we're going to have 4 pi over 3 plus n times 2 pi. And then the last one's going to be 5 pi over 3 plus n times 2 pi. And you're wondering probably how I got that. So if I go back to my unit circle, and if I were to erase this here, and so if I said it was pi over 3, so that means that I had one reference angle right here. And so that's the first one, that's the one we solved for. So that means I get to use 60 degrees here, and that's where I get the pi over 2, so because this is 60. And then I get to use the next one, which is 4 pi over 3, which is this reference angle is 60 here. And then the last one was 300, which was 5 pi over 3, because this is 60 degrees, and theta here is 60 degrees. So it's being able to go back and forth between degrees and radians, and finding out the appropriate values for our trig functions. Last one we have is cotangent squared x minus 1 equals 2. Same deal, we're going to add 1 to both sides, so I get cotangent squared x equaling 3. Now all I have to do is just take the square root of here, so now it becomes just cotangent x equals plus or minus the square root of 3. If you go into our chart in our unit circle handout, it tells us that x in degrees, if you were going to take the inverse cotangent of the square root of 3, you're going to find out that it's going to be 30. And then in radians, this is pi over 6. So using our reference angle of pi over 6, or 30, we can determine that our 4 values I'm going to get pi over 6 plus n times 2 pi, because it could be any general solution. Then the next one's going to be 5 pi over 6 plus n times 2 pi. The next one's going to be 7 pi over 6 plus n times 2 pi. And then the last one's going to be 11 pi over 6 plus n times 2 pi. So that's what we're looking for when it comes to solutions with either squared or 1 degree trigonometric equations. So if it's 1 degree trigonometric, it's going to have 2 solutions. If it's squared, it's going to have 4. Okay? These examples are not general solutions. All of them are from a specific interval. And here, the specific interval is between 0 and 2 pi. So the difference between these problems and the problems we did on the first page is that you don't have to put the plus n times 2 pi in. You know which ones it's going to be because the parameters are just between 0 and 360 degrees, or 0 and 2 pi. But the process is still the same. We're still going to try to isolate our square values. So I'm going to go plus 1 plus 1. So that gives me 4 tangent squared equals 1. Then I got tangent squared equals 1 over 4. Take the square root of this. So now I got tangent x equaling plus or minus 1/2. So from here, if I look at my tangent values, it does not have 1/2 is one of its special values. So that means I must take the inverse tangent of 1/2, and that ends up equaling something like 26.57 degrees. And if I wanted to put that into radians, I multiply it by pi and then divide it by 180. So that means that the radians of this is going to be x equals 0.46 radians. So from here, I get to determine which other angles this is going to be, because it's both also positive and negative. So if I took the inverse tangent of negative 1/2, I'm just going to get a negative 26.57. So that means that it's going to be a negative 0.46 radians. But if I put this on my chart here, like if I made it, my reference angle would be, here would be 26.57, and then here would be 26.57. Here would also be 26.57, and then here would also be 26.57. So that means I'd get to find each one of those degrees and being able to find the solutions for those specific values. So let's take a look at quadrant 1. We already have it's going to be 26.57. So to find the one in quadrant 2, I take 180 and subtract it by 26.57, and I'm going to be left with 153.43. To get the one in quadrant 3, I just take 180 and I add 26.57. That's going to leave me with 206.57. And then the last one is I just take 360 and subtract it by 26.57, which leaves me with 333.3 degrees. Now all I have to do is figure out, and I'm just going to deal with the positive radians. So that means if I take 153.43, multiply it by pi, and then divide it by 180, I'm going to get a value of 2.68 radians for that second quadrant. And then if I go 206.57, multiply it by pi, and then divide it by 180, I'm going to get 306.61. And then the last one's going to be 333.43, multiply it by pi, and then divide it by 180. And then the last one's going to be roughly about 5.82. Okay. Let's give one more try. Let's give B a try. So if I have 5 cosine squared x minus 3 equals 1, so I'm going to add 3 to both sides. So I get 5 cosine squared x equaling 4 divided, then I'm going to divide it by 5, so I get x equaling 4/5. Taking the square root of this, so I got cosine of x equaling, what would be, 2 over the square root of 5. But if I multiply both sides by square root of 5, so I get 2 times the square root of 5, all divided by 5. So now 2 times the square root of 5 divided by 5 is not a special trig ratio, so I must take the inverse cosine. This is going to be plus or minus 2, I'm sorry. So it's going to be 2 times the square root of 5 divided by 5. So if I punch that into my calculator, 2 times, let's find out what square root of 5 times it by 2 divided by 5. I get like 0.8 something. So if I take the inverse cosine of my answer, ironically I get the same value that I got in, so that means that my x in degrees is going to equal the 26.57, which is kind of ironic. It's going to be the exact same thing as we had in example A, so that means that my radians in this case is still going to be 0.46, it's still going to be 2.68, and it's going to be 3.61, and then lastly it's going to be 5.82. So it's the same angle, same degree in radians, so but different problem to help you solve it. And that is being able to solve trig functions, part 1. So I'll get the rest next time for part 2. I hope this helps, and I'll see you next time.